Hello everyone, welcome to Mayur Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is find the length of the longest common prefix. So the problem statement goes like this. You are given two arrays with positive integers, array 1 and array 2, and a prefix of a positive integer is an integer formed by one or more of its digit. Okay, so for example, 1, 2, 3 is a prefix of 1, 2, 3, and 4. Okay, while 2, 3, 4 not 2, 3, 4 not is not the prefix. So see this is the prefix. This is also a prefix. Okay, and this whole is also a prefix. But you see, this particular is not a prefix because it's not starting from the very first digit from left hand side. Okay, so a common prefix of two integers a and b is an integer c such that c is a prefix of both a and b. Okay, so for example, let's say these are two integers given a and this is b. Okay, so have a common prefix of 565. See, 565 is present here also and it is present here also. Okay, and while 1 2 3 1 2 2 3 and 4 3 4 5 6 do not have any common prefix, so you cannot have any common prefix in them. So this is what a common prefix is. Okay, they are trying to give an example about, to make you understand what a common prefix is. Okay, and then you need to find the length of the longest common prefix between all pairs x and y such that at x belongs to array 1 and y belongs to array 2. Okay, so return the length of the longest common prefix among all the pairs. Okay, and if no common prefix exists, then you have to return 0. Okay, before thinking of an approach, let's have a quick look at the constraints. So according to the constraints, the length of both of the arrays will be of order 10 raised to power 4. Okay, and then it is mentioned that each entry in these arrays will be of order 10 raised to power 8. Okay, so these are the constraints. So let's try to think of an approach. So see, if you are thinking of a brute force way of generating all possible pairs, okay, to generate all possible pairs and then check common prefix length among them. Okay, generate all possible pairs. Okay, and then do what you are supposed to do. Even for doing this much, let's say the array 1 is of length L1 and array 2 is of length L2. Okay, both of these length order of these lengths we know that L1 and L2 will be 5 into 10 raised to power 4. Okay, so even to generate these combinations, you will be requiring something in terms of L1 into L2, order of L1 into L2. Okay, and it will exceed basically 10 raised to power 8 operations. Okay, so there is a operations limit. The number of operations required by your program to solve a particular problem should be well within this limit. Okay, and it will not be within this limit even to generate all possible pairs, let alone doing some extra work upon that. Okay, so in order to get our solution accepted, we need to have optimizations here. Otherwise we will end up getting time limited exceeded error. Okay, and the solution will not be accepted, so it needs optimization. So in order to optimize it, what we will be doing is, see, if you are not familiar with our data structure that I will be introducing, it will be try, Okay, so then I will provide link of an article explaining what try is. Okay, and although we are discussing a little tweaked version of it, but you should be familiar with the try data structure, if you want to proceed further down this solution walkthrough. Okay, so I would highly suggest you to go over that link and read about it and see its basic implementation. Then you will be able to understand how I was able to think that try will be applied here. Okay, anyways, let's discuss how we can apply try here. Okay, so see, the number of digits in this particular range, if let's say it is the maximum number that can there be 10 raised to power 8, so 8 zeros and then 1 9. Okay, uh, then 1 total you can say 9 digits. Okay, so at max 9 digits can be there. Okay, so what you will be doing here is you will be having an array. Okay, basically uh, you are trying to create a class, and then you are having a array of objects. Okay, nested in array format. So I think it will be better if I show you the code, then I will be able to explain you in much clearer way. Okay, so for explanation also, let's bring the code to the board. Basically, for this kind of problem, if you are familiar with try, then it's very easy, and it will not take you much of thinking that how and when you can apply try. So suggestion, I would again suggest you to go over that link and familiarize yourself with try data structure. Okay, so let's see how we have implemented try and use it to solve this particular problem. Okay, so we will be having a class, okay, which will be denoting the try data structure. So our version of try data structure will be having following things or following elements or properties. The first one is the children. Children is nothing but, suppose there is a root. Okay, it is having some children or neighbors of it which are directly attached to it. Okay, and we are storing those neighbors in the form of an array. Okay, that's the only difference. uh, Rather than doing just straightforward connections, we are storing them in array. Okay, in order to get fast access also. And then this there will be two variables representing the whether the current node is from the first or the second. So see, what's the logic behind it is for example, for the first thing that I noticed in the constraints was that only 9 digits will be there at max. Okay, so if a number is given to you 1 2 3 4, okay, and if you try to break it into digits, so separately, so 1 will be separated, 2 will be separated, and then 3 will be separated, and then 4 will be separated. So you can adjust it into the try. Okay, so let's say the indexing of this particular, and see, from 0 to 9 indices, you can accommodate all those digits. Okay, that's why I took the size of the children's to be 10 children's array basically. Okay, and those will also be the try node. So let's say this is the root. Okay, and you want to fit 1 2 3. Okay, so let's mark the indexing. So the indexing will begin from 0. Okay, 0 1 2 3 and 4. Okay, then you will first traverse these digits one by one from left to right direction. Okay, so from this direction you will be traversing them one by one. So when you will be at the first digit 1, then you will try to insert it into the try. Okay, for that you would be wanting to have the index at which this insertion is to be done, and that index should be 1. Okay, so first of all, the very first thing, let's say I want to insert a particular number, this is num, into the try. Okay, so first of all you will be having access to the root of the try. Okay, and it will be having some childrens. Okay, so these are the childrens of the root. Now further down the line, these childrens might be having some childrens of their own. Okay, for example, one can have childrens of its own. Okay, and then we will again mark the indices of those childrens. Let's say for now the children size is 4, although it will be 10. Okay, then you see 2 can also have its childrens. Okay, so same thing will be applied to 2, again marking the indexing. Okay, so this is not there, we can remove this one. Okay, so see, if you want to fill 1 2 3, then you will see 1. Okay, what is the index that we should be filling it in? It should be here. Okay, so it is filled. Okay, then you will see what node you have filled the current digit. Okay, you filled at this particular node, you will seek the childrens of this particular node. Okay, so you are going in a depth wise way and storing digit by digit. Okay, so next digit 2 will be stored here. Okay, so a node will be here, so it will be stored. Okay, and then you have to store 3. So what was the last node at which you did your insertion? It was this node. Okay, then you will seek the childrens of this node and then store 3 there. Okay, so this is essentially what we will be doing, and how it will help us to reduce the time complexity is we will be introducing 2 variables, boolean variables basically. They will be representing whether the digit is from the first array, numbers in the first array, or it's from the second numbers in the second array. Okay, so let's give them separate colors. So let's say yellow one is for the first array and the green one is for the second array. Okay, and let's say there is another number, uh, let's say there is 1 and 2. Okay, so basically this kind of 1 and 2 will be having both colors. Okay, so they will be in a way having both colors. So you will what you will do is you will do a depth first search, DFS. So if you are not familiar with DFS also, I will also provide link of this particular one also. Basically what you do is starting from a very first node, you go till the depth till you cannot go any further, and then you trace back your steps one by one, and then see if there are any possible other paths to explore. Okay, so for the current path you go till the very depth, as far as you can go, then you backtrack your steps one by one and try to explore others. So that's why the name depth first search. Okay, searching the depth first. Okay, so you will be doing that kind of traversal, and what will be the overall condition for doing that depth first search? The whole condition is that it should be having 2 colors. Basically the digits should be from both of the arrays. So if we start our DFS from here, okay, and for 0 it is not having any depth, and 2 is not having, 3 is not having, 4 is not having, only 1 is having. While exploring the childrens of root, when you will arrive at the one, you will start exploring its depth. Okay, because it is the only one in the childrens of the current root which is having any depth. Okay, so you will go into the depths. Then again for all these there are no depths. Then when you will be at 2, you will be exploring it further down the line. Okay, then you will come to a point where there is either there is an dead end, or the current node that you will be finding is not uh, having both of the colors. Okay, so you will stop then and there only. Okay, and you will keep one variable max length. Okay, and you will keep updating the maximum length you were able to reach while doing that depth first search. Okay, so this is the whole logic. Now see now let's see how we have implemented this. Okay, so I have already told you the insertion part. Okay, so this insertion part I have already told you. So see, each try node will be having some children, and e- each of those try nodes will be having two variables associated. The first variable is whether this digit in the current try node is from the first array or it is from the second array. Okay, so then what you will be doing is, once you have formed this structure of try node data structure, then you will go to your class that or the function that you have to complete. This is the function. So then before that you will initialize one global variable max length, which will be the variable, by the way, which you will be returning from this function. Okay, and you will be getting two inputs, array1 and array2, as mentioned in the problem statement. Now once you got those inputs, you will try to insert all of their numbers into the try. Okay, so traversing these arrays in a linear fashion and trying to insert all of their numbers. Okay, and see, true is representing that this particular entry is from the first array. Okay, and if it is false, then it means that it is from the second array. Okay, so let's see how things are happening inside the insert function. First of all, we are converting it into a string so that we are able to do the traversal from left to right direction. Okay, without any hiccups or extra implementation. Okay, so then once you have converted into the string, then what you will be doing is you will be storing the address of the current root. Okay, which will be the root that you will be initializing here. Okay, so then once you are having that, or the reference of the current root, then you will be, see, this will be a string, so you will be traversing this character by character from left to right direction. Okay, then to get the index at which you have to do the insertion, you will take the relative difference of the current digit with uh, this 0. Okay, so this will give you the index at which the insertion is to be done. For example, if you do this, then you will get this. Okay, so it is the index, integer value. Okay, so then once you have the index, you will do the insertions just like we were doing here. Okay, in this whole procedure. Okay, one by one you will keep doing so, and once you are having hold of the index, you will check whether the current entry, current node, or the entry at which this insertion is to be done is null or not. Okay, if there is no node before this insertion was done, then you will make that node. Okay, here we are making that node. Once you are having that node, so you will do a, you will set whether it was from first array or the second array. Okay, so this is that logic. This will set whether it was from the first array or the second array. Okay, basically you are setting your colors here. Okay, so once you have done all that, then you will going to your next route, or the new route will be made at which the current insertion was done. Okay, just like it was happening in the case of 1 2 3. So when you inserted 1, your new route become this one. Okay, so this is what you are doing here. Okay, so once you have done all this, you will have your try representing both of the arrays, numbers in both of the arrays. Okay, and then what you will be doing is you will be doing a DFS, from the current root. Okay, so this is just a DFS, this function, depth first search, starting from the current root. See, depth is the length of the the maximum depth till which you are getting both of the colors will be the longest common prefix. Okay, length of the longest common prefix. Okay, so initially your depth will be 0, and at each step you will be updating your depth to this maximum length by this maximum length variable. Okay, or maximum length variable will be updated by the depth. Okay, it is the other way around. And then for the current root you will exploring all its children. If any of its child is not null, it means that it is having some value and there is a node. In that case you will check whether this particular node is having both of the colors or not. It means that this digit should be having contributions from both of the arrays. Okay, then you will keep exploring further down the line if these conditions holds true, and you will keep updating your maximum length. And when you will be done with this DFS, your maximum length will be representing the length of the longest common prefix among all the pairs possible among these two arrays. Okay, so this is the whole implementation. And if we want to have a discussion about the complexities, so see, let's clear this thing a little bit so that we can have a discussion here. I think now it should be fine. So let's say the arrays were having sizes of, let's say array 1 is having length 1. Okay, and array 2 is having length 2. Okay, so see, here whatever, let's say on an average the number of digits in their numbers in their uh, numbers that they are having is d. Okay, d digits on an average. Okay, so total how many digits will be there? Total len 1 plus len 2 into d digits are there. Okay, let's say the total number of digits. Okay, so in order to store all those digits you will be needing something of the order len 1 plus len 2 into d number of auxiliary space, you can say. Okay, so this is the space complexity. That much space will be needed by the trie to store all the digits. Okay, and now talking about the extra space that will be used in this particular recursion that is happening in this DFS approach. For that, let's say the maximum depth is the maximum number of digits in a number. Okay, which is, let's say on an average we were saying it was d. Okay, order of d. So see, comparing these two, this is obviously the greater one, so space complexity will be this. Okay, talking about the time complexity, see, we are doing a linear traversal here, digit by digit in this particular one. Okay, and since it was a linear traversal, let's say again have that logic that there are d digits on an average, and so the overall time complexity because of this linear traversal and this particular, you know in this case you could be visiting all the possible try nodes that are there. Okay, so time complexity will also be this. Time complexity will also be order of length of one length of the first array plus length of the second array into number of digits. Okay, so or average number of digits. So this will be your time complexity. Okay, so these two are the complexities. And if you are still having any kind of doubts or any queries in general, then you can ask them in the comment section. And I really hope this solution walkthrough added some value to your journey of honing your DSS skills. Keep solving more and more problems, and I will be seeing you in the next video. Thank you for watching.